Okay. Well, I don't know. I'm not sure, actually. I don't have the answer to this yet. So, let's see. Looking at problem 21, 2010 NECAP. It says, what are the coordinates of the point where the lines y equals 2x minus 1 and y equals 4x plus 13 intersect? Show or explain how you know, blah, blah, blah. So, based off of the words, they were looking for coordinates. So instead of an x equals y equals solution, which is what we've been doing, they'd probably want it presented with some sort of, parentheses, comma, parentheses setup. What I want to point out is if I was to graph these, y equals 2x minus 1 and y equals 4x plus 13, both of these are in y equals mx plus b or slope-intercept form. So the slope for this first equation is 2 or 2 over 1 if you wanted to think about it that way. And the y-intercept is -1. Here the slope is 4 and the y-intercept is 13. And actually, I'm just going to quickly graph it here in my little geometer sketch pad here. So 2x minus 1. Bam, there's our first line. And if I graph 4x plus 13, there's my second line. So if I was to graph these by hand, what you would do for, say, the first line is you'd go down to -1 for the y-intercept, and then you'd go up 2 over 1, up 2 over 1, up 2 over 1, plot some points and draw them. And then for the second line, you'd go up to 13, which is the y-intercept. You can see that's where it's crossing. And you'd go up 4 over 1, and you realize, man, I really don't want to draw that high. But a slope of 4 over 1 is the same as a slope of -4 over -1. So you could also go down 4 and backwards 1, down 4 and backwards 1, and you could plot some points that way. And it appears as though the intersection here occurs, let's see, yeah, it looks like that's where it is about, and I can actually measure the coordinates. Bam, right there, -7, -15. Appears to be the case, right? Good stuff. Good stuff. So this is a graphical solution. Actually, let me even thicken up these lines a little bit. Line style medium. I didn't teach this to you yesterday. But you may have seen it in maybe Math 1 is when it's taught. I'm not entirely sure. So here's a graphical solution. Now the things that I hold as penalties against graphing, or my reasons for not liking that method that much, is it's kind of a pain to get your grid to fit right, because you would have to kind of know in advance where your intersection would lie. It's not very accurate. For instance, what if the solution here was -6.512 and -15 and 7/8? Like, I'm not going to be able to get that accurate if I was graphing, especially by hand. I mean, this might, as a computer tool, it might be okay for a little bit. But yeah, so graphing is just not very accurate. And then it'd also be inconvenient. What if my solution was way out at like 1,000, 2 million? Like, I don't want to have to draw that coordinate plane. But the nice thing about solving algebraically, all right, which means not using a graph, right, is that I will be super accurate every time. Although sometimes graphically it does have a nice visual representation. If this was, for instance, a word problem, and each of these lines represented the costs of 2 different cell phone companies, I could kind of get a visual understanding of, like, okay, if my minutes are less than this is when this company's cheaper, and if my minutes were more than this, that's when that company's cheaper, or whatever. But we're just looking for the intersection here. So if I wanted to solve this by substitution, I would solve one of the equations for one of its variables, and notice both of these equations are already solved for one of their variables. They're both solved for y. So that means that if 4x plus 13 is equal to y, I can plug it into the other equation's y. You also could have taken this guy and plugged it in that equation's y. It doesn't matter really at all. So I would have 4x plus 13 equals 2x minus 1. And I would solve that, bring the x's together. I usually always move the little guy to the big guy, but it doesn't matter. Little guy to big guy will often give you a positive coefficient though, which can be nice. Let's see, then we subtract 13 from both sides. Let's see, I'm getting a little bit quicker on my color swapping here. And I think I see the -7 showing up here in a moment. Yeah, that's an ugly 2. Bam, bam. And I would have x equals -7. Now that's not the whole solution. In order to find the other solution, typically what I'd have to do is then plug this into one of the equations, usually the revised equation because it's already solved for the other variable that I'm looking for. So then you'd have y equals 4 times -7, plug it in with parentheses just like Indiana Jones would, plus 13, and y equals what, -28 plus 13, and that appears to be -15. And since they wanted it written as an ordered pair, we'd write -7 comma -15 like so. So that represents, you know, x position, y position, sort of thing like that. So, good.